So, hello everyone. My name is Eli Koshrovsky, and I'm a product manager at DriveNets. So, really happy for the opportunity to be here and talk to you today. And I'm going for the last part of our day, and I'm going to do, well, at least our session, and I'm going to do the multi-router demonstration. So basically everything that we have been talking about so far, we're going to do a short demo and just demonstrate the key strength of our product, at least that we see them. Let's discuss a little bit of what we're going to talk about today. So, two main points. The first one is the DNOR, and the DNOR, as have been said before, is our orchestration system. So, as my colleagues and previous speaker has said, we are basically taking the white boxes and we are collecting, and they are bringing them together, gluing them together into a single cluster or a single pod. So one of the key components in enabling that functionality is the DNOR, is the orchestration system. That's one of the things that glues everything together into a cluster and really helps in the operation of the whole system. And the second thing we're going to talk about today is the power of software-based networking. So two main components here. The first one is the instant service deployment. So instead of deploying your system as a hardware routing, racking it up, connecting everything, and powering it up and configuring, and you probably know the procedures here. For us, it's a matter of software configuration. Okay. The second part is the elastic allocation of physical resource, and this is very unique to DriveNets. And this has been mentioned by Amir before and by Ran as well. The utilization of the network is not constant throughout the day and throughout the resources. There has been a question about DDoS as well. The option or the ability to reallocate resources on the fly between different SIs or different routing instances, our term is SI, is a key ability to allow very efficient resource utilization throughout the day, and basically provides the best way to operate the hardware, because we keep it on a constant high load instead of having kind of the high utilization and the low utilization periods. Okay. I mentioned DNOR before, but the very important components of it are, again, we're talking in twos today. So the first one is top to bottom hardware orchestration. So all the cluster management, all the component monitoring and the fault management and performance management is done and managed by DNOR. Okay, so this is our orchestration, and that's the part that manages the hardware. The second part is the end-to-end service orchestration, which means that we instantiate our services and monitor them and keep the marketplace that basically allows the service providers or whoever runs the system to keep track of the actual services that have been certified and are capable of running on the system. The kind of higher level presentation of that would be a DNOR has two pillars, which is the cluster management that takes care of the pod state and the deployment and upgrade and the life cycle and the fault and the alarm parts. And we have the service manager, which takes care of the SI state, the deployment and the upgrade of the SIs, and the fault of the alarms. Eventually, the system manages several pods, which allows you to have a very wide view on the whole system. So I'll go to the actual DNOR screen right now. This is the main map. This allows you to see that we have different sites in the system. Okay, we actually have just two systems connected, but the idea is that you will manage several locations. And let me just take it a little bit here. Okay, you will be able to manage several locations, and you will be able to look at the different systems that we have here. So we have two systems here. Okay, so one is a standalone, which is basically a single device. You can take a look at it here. Okay, it's a single device. It's a device of 4 terabits, and it has 10 400 gig ports. Okay, the second device is a cluster, which is an 8 terabit system with a single fabric and the 2 management and 2 control plane functions. So you can see from here, okay, the way that the control links are connected, that basically allows you to see how the system is interconnected in terms of the control plane. And the other way to look at it is the actual fabric connection. So this is the data path. This is actually where your bits and your packets live, okay? Now, besides the different physical connection, you can also see the different components of the system. So that's basically what manages the cluster, okay? So this are the different containers. This is everything that we are doing in order to keep the system working, okay? Now, that's the part of the hardware. Now, the second part we're going to take a look at is the service catalog. So here we are actually going to the multi-service piece of this presentation, where basically, in order to create an SI or a service instance, we need to have 3 things. The first one is the image. The image is the actual code you are running in order to make the SI work. So in this place, you will basically just upload a file which will have some kind of manifest or different metadata files with it that will describe how this SI looks like. And then after it has been certified, it's being uploaded in the system. So it's a process that takes several minutes, and we have some images preloaded here. The second piece is the flavor. Now, the flavor defines how large is your service going to be, and this part is completely dynamic. Now, think of it that you can create a router which has different form factors. Now, if you're speaking of a chassis or a monolithic router, you basically have to decide on the size of the chassis you are buying at the moment of the procurement. Now, here it's something that's completely dynamic. So you can get a router, it can start its life as a small one and kind of increase in size. Now, the way that the flavor is defined is by the different compute resources it uses from one point of view, and from the second point of view, the amount of networking resources it uses. So the number of interface, the amount of FIBs and the FIB entries and the VRFs, ACL, so different parts that actually define the data path, okay? Now, and the place all of it comes together is in a service. A service is a place where you take a certified code and you pair it with the option of flavors. Now, that means that I'm taking this DNOS and I'm saying this DNOS can run on this and this and this flavor, means it can go small, medium, large, okay? You can do some description, different configurations. The permissions is a very important part of it, because in a system which has multiple instances running on it, different people might not be able to modify all of the components. So you may decide that certain service instances can be changed by one set of people or a certain permission of groups and users, and another SI can be changed by a different group of users. So this place here allows you to do that. Okay, so the second step of our demo is going to be an instantiation of an SI. Now, let's talk a little bit about the flow we're going to take. Now, the first thing we are doing is we're choosing a geolocation, okay? So we basically need to decide where we are going to run our service. After that, we are choosing the service, meaning what we're going to run. We're choosing the flavor, meaning the size of it. And then we're choosing the network interfaces that are going to be attached to it. Now, in terms of where things live, currently the SIs, the compute part of it, or the control plane, is living on the NCC. So that's basically the server that manages the cluster. While the data path components, so this is the RIB, the ACL, everything that has to do with the actual traffic handling is living in the NCPs. Now, the NCPs are the places that the ports are located. And what you will see right now is we are going to go to the system. We're going to allocate different ports, and you will see how that reflects in the different SIs, okay? So I'm going back to the system. Okay, so we're going to the actual system, and now we're going to take a look at this specific place. Now, okay, so we're going to the services part. You see that nothing is running here. We can also connect to this. Okay, so I'm opening an SSH session. This is just a regular SSH session running within the browser. Okay, and you can see that currently there is no service instance. Nothing is running here. Okay, the next thing that we're going to do is we're going to deploy a service. Now, the service we're going to deploy is our core service. Okay, so we're going to take the service. Let's call it core NFD1. Okay, let's say that it's a large cluster, or a large instance. Now you have an option to create to run it in different HA modes. Now the cluster is responsible for keeping the SI alive to a certain extent. There are different facilities the cluster can provide, and this is basically the way to put them in. Will we restart the different containers, or we will not restart different containers, and how distributed we want it to be over the cluster. So this one is going to be full HA. Okay, so now I'm deploying the system, and I'm deploying it with a single port. Now, this operation takes some time. Okay, we'll get back to this instance a little bit later, and I'm going to move to a different cluster that's running the two instances that we have pre-installed. We pre-deployed them just to make sure that, you know, to save time. So I can go into the terminal and, okay, so this is an SSH connection to the cluster. Okay, so it just takes a second until we connect. Okay, so in contrary to the first system that we have seen, here you can see that there are two service instances that are already running. Okay, so what we're going to do now is we're going to go to the core NFD system. Okay, so this is one of the components we have here, one of the SIs. Okay, we're going to open a CLI screen. Now, this one is not going to the hypervisor level, meaning the system that hosts the whole thing, but it's going to the actual SI. Okay. Okay, so we're opening the connection to the SI, and you can see that it's a system. It's basically a virtual router, okay, that's called Core NFD. And if you'll take a look at its interfaces, they're currently just a management interface. Okay, so what we're doing right now is we're going here and we're going to assign some interfaces to it. Okay, so let's give it 4 100 gig interfaces. We have two NCPs here, NCP0, and NCP3. Okay, so those are 4 ports we are allocating. And now, once I push the update button, what you will be able to see in about a second, or more like 5 seconds, is that the ports are being allocated dynamically to the system. Okay, so everything here is disconnected because that's the reason you see that it's down, but you see that the flexibility and the power of how we are assigning interfaces to a system. Now, it's done completely dynamically. We're going to go to the other system in the cluster, okay, which is the peering one. Okay, so we are opening SSH to the second SI, okay, to the second. This one is the peering one. So we are doing pretty much the same thing. Now, there are no interfaces here right now, okay, so okay, so now we're going to assign a different set of interfaces. Okay. Okay, so now what you can see is that the interfaces are going to be assigned to that SI as well. So it's basically the same procedures we have seen before. So now let's go and take a look at how it looks from the topology of the cluster itself. Okay, so 2 things we can see here. The first one is the way that the containers are defined on the cluster. So you can see that our core 4 containers and peering 4 containers are running on top of the NCC. Okay, now the second part here is that then we are going to the NCPs, which are the packet forwarders. Okay, just a second. And we'll take a look at the port status. You can see that there are different ports here, and you can see how the ports are allocated to the different SIs, okay, to the different service instances. So we're doing it here. We can do the same thing here. Okay, so the ports that are in blue are basically assigned, and you can see in the tooltip on the bottommost part of it that the port is assigned to a specific SI. Okay, so and now if we're going back to our peering SI and see that the ports were allocated, okay, so you can take a look and the ports have been successfully allocated to the system. Okay, so do we have any questions on this part?
Yes.
Yes, please.
And I know the answer, but I just want to ask for clarity.
Okay.
Because you're in a container there, you are doing physical pass-through of the interfaces into that container, right? No funky proxy, any kind of manipulative natting or anything like that?
It's a very, very good question. Now, the answer actually has two parts. The control plane part of it is that we're just getting the packets and through a GRE tunnel, pushing them through the data path part to the controller part. Now, that's just for us and to us and from us traffic, okay? But in the actual data path, okay, this is the intellectual property. This is what we do. So we were able to virtualize the data path to an extent that we can do in parallel two virtual routers, okay? This is no NAT, no nothing. Those are two separate routing tables, two separate interface sets, completely separate data path implementation in the forwarding layer.
Thank you.
Sure.
Perfect.
Thanks for the question, Larry.
Absolutely.
Now, the last piece that we're going to do, this is in my opinion, at least the most powerful thing that we can do. Now, as you have seen before, we have assigned 4 interfaces to every SI. Now, because that's what I needed at that specific point of time. Now, conditions have changed. Maybe COVID has hit, maybe COVID has hit, maybe something else has happened, okay? And now what we need to do is we need to reallocate the ports, okay? So when we need to reallocate the ports, what we are basically doing, we are going here, okay? We're going back to the service instances. We're going to the service instances, and what we'll do is we will remove them from one point, okay? So we'll remove them from here. For instance, let's remove port 3 and this port 3, okay? We're updating the system, and then what we'll do next, we'll go to the services, we'll go to the NFD piece, and I'm just doing it for the sake of time here, but you can see the ports that are appearing here, and you're just updating them back, okay? So basically, that's the procedure you're doing, and that allows you to reallocate the ports from one system to another system. That's as easy as that, okay? Now, think of it on the power of it. So if you have DDoS, okay, and things have happened and you need more capacity, that will allow you to reallocate ports as you need, okay? Think of it that capacity has grown and you need to attach different ports to different SIs. That's basically the power of this, okay? Okay, so I'll get it back to Ron, who is going to summarize our session.
I hope you understand how unique this demo was. This actual running of 2 separate, completely independent routers on the same infrastructure, and the same physical infrastructure, each allocated with its relative or respective resources, and of course the shift of resources from one to the other, which can be done dynamically. The parallel to this would start from budgeting, right? It would start from the CFO office and going into the network and deploying more equipment. And the shift of resources between one instance to another, it's simply put impossible with traditional networks today. So this is what it means when networks are built like cloud. So for me, bringing you back to the three pillars, the three benefits of what does it mean to run like a cloud. Cost reduction clearly coming from the place of capital expenditure and operational expenditure, as was explained throughout the session. The ability to scale hardware perspective or data plane perspective, as well as control plane perspective, or should I say application perspective, each independent and can scale to required size, essentially without any real limitation. And obviously innovation. Once all of this infrastructure is there, and with that kind of level of flexibility, then introducing a new service, the first cost curve is thrown out the window, and we're able to just launch new services instantly, as you've just seen, into a real live operated network. This is granted because we're, again, building it like a cloud, virtualized hardware using standard uniform form factors, and obviously software, which is cloud native, intuitive structure of the software, and distributing it over the complete cluster. That's the wrapper from our end. Really appreciate the time that you guys have spent with us. If there are more questions, we'd be happy to take, and to all of you folks at home as well, thank you for staying tuned with us.
I was just kind of thinking about how different this is from your traditional 3-tier architecture and that kind of thing. So for network engineers that are used to troubleshooting a certain way, what kind of dashboards and information do you get within this environment to kind of help you figure out if things are going wrong?
Well, it can be reflected to traditional, what we call traditional users, just like it's a traditional router. So the same attributes, the same way that you're used to, if you're used to using a CLI, go ahead and continue to use the CLI, it's there. Most of our customers do not go in that direction. They're going into the more modern way of kind of a single pane of glass, using DNOR as the element that orchestrates the complete cluster as a whole. So if you're troubleshooting that, then you're troubleshooting a router, just like you would a traditional router. And if you want to look deeper down, then you can look into the deep insights of the fabric, because again, the fabric is a physical interface in this case. And of course, every subcomponent of that is also being tracked. So you have much higher level of granularity in terms of what kind of insights you can be looking into within the cluster or within the network. And of course, you can bring it back to your traditional methods. Both options are supported.
So I assume you could telemetry data. I can still send syslog and things like that.
Trivial, yeah, of course.
Okay.
It's a router. It's a routing running on an infrastructure rather than on a monolithic chassis.
I've got a real quick question on how are you guys seeing everybody use it from an automated perspective, being able to deploy this, these routers and things like that. Obviously, you have an API, things like that. Do you see folks using things like Terraform, Ansible, anything like that, being able to provision everything within the platform itself from code?
We've been having some discussions around this with some customers. It's not very common, but we have seen that. Taking that into a direction of kind of scripting scenarios is not too common, because the variance of use cases is so wide. Unlike what happens within the data center, but definitely we are having these discussions with our customers. Yes.
Cool. Thank you.